Okay, so let's get started. Welcome everyone. Welcome again to our ladies' room. My name is Federica Gazzelloni, and I am the lead organizer of this chapter. We are a nice community of learners, and what we enjoy most is sharing our learning. It's all free for you to grab, and so please stay tuned because we do one event a month. And if you have any suggestions, any topics that you are interested in particular, please put in the chat or get in touch and we will be happy to arrange that for you. All right. Today, our event will be all about text analysis in R. And so we are going to talk about tidytext and local large language models. What is our mission? Is we love to provide free learnings and to everyone. And so our community, it's a local chapter of a larger community, which is Our Lady Global Our Ladies organization. And we are promoting free learnings in the R programming community. And so what we do is hosting workshops, talks, nurturing events, create a safe, and welcoming, and collaborative space for all skill levels. And so our global community now reached more than 200 chapters, and they are active worldwide. We are spread around 50 plus countries, and we are open source first. We like to build a supportive network for especially underrepresented genders, empowering thousands of data scientists, statisticians, researchers across the globe. So let's celebrate a bit. Our ladies from so can show a significant increase in membership and such as active participation. Our community is focused on data science over the past years, and what we do is basically connecting academia industry through fostering the use of R, collaborations, and career opportunity for our members. So what we do most is hosting expert voices that are happy to share their learnings, and they come from a very diverse background. So please stay tuned because we always do more. What is about Our Ladies Room in numbers? We hosted 50 plus workshops, and our chapter run since 2023. We had 1,000 plus speakers and 20 plus country represented. So now a bit of a news and just a logistic preceded a change. We are moving from meetup to our events. Primarily, our events were hosted on Meetup, and that will still be there for a little while more. But then, so we are slightly moving to using luma.com for our event registration. This is just, to let you know but it's just a logistic procedure. So what's happened next at Our Ladies Rome after this May event? On June, we host Buenos Aires Our Ladies chapter, and we will be talking about academic manuscript with Quarto. So stay tuned because we are going to show how to use Quarto for academic, integrating workflow, GitHub, and so just to be able to understand a bit more how to use it for research practice. Then July will be like a summer networking mixer. So we still don't know if it's going to be in person or online. And then we just have an idea of what's going to happen on September. In September, that will be all about machine learning. So without further ado, I like to introduce a bit more about our guest speaker today, Dr. Maria Mykhailyshyna. She will say it better than me. So she's a postdoctoral researcher in economics at Kyiv School of Economics. She's an expert in political economic migration and causal inference. She holds a PhD in economics from the University of Bologna and has over 7 years of experience in R in applied research. We are honored that Dr. Dariia accepted our invitation, not even only for a great community impact, but for her expertise. And so thank you very much for joining us. And I thank you, everyone, to join us today, and pass the word to Dr. Dariia. Thank you very much.
Thank you so much. So let me share my screen. Let me find part of the screen I want to share. Yeah, I have a lot of open. Yeah, okay, this one. Yeah, so first of all, thanks a lot for the invitation. Just a disclaimer beforehand that I have all of the materials for today's talk on my GitHub, which is public, so you can go through code on your own, and you can like look through the slides maybe on your own pace later. And yeah, it's all in here. Let me just quickly send it in the chat so that everyone can also see it. But today, I will mostly go through the slides, and there are some bits of code in slides as well, so that I can show you what exactly I'm doing. And if you have any questions at any point in time, feel free to either write in the chat or ask verbally. So as Federica already said, today I will talk about text analysis in R. Specifically, I will talk about how to do it in a traditional way with keyword method, with dictionaries, and also more modern way with LLMs and with local LLMs as well. So also, as Federica already said, my name is Dariia Miasnikova. I am a postdoctoral researcher in economics at Kyiv School of Economics. And this talk actually is based on the part of the course I teach there, so it's related as well. So just to give you a little bit more information, so first of all, I will talk about text analysis in general, why you should be interested in it, and why in which cases we can use it. I will also introduce the data set that we will look for in this session, and then the rest of it will be structured around two parts. In the first part, I will go through the traditional pipeline with tidytext that has been used by people who work in R for many years now, and this is established pipeline. And in the second part, I will more look into LLMs, how to use them for text analysis, and specifically look at the mol package, which allows to do it quite easily. So why should we look at the text analysis? First of all, there is a lot of text everywhere. right? So there are social media posts like news articles, uh, parliamentary speeches, but also like in the uh, surveys, there are open-ended responses. If you're more kind of not in academic, but let's say in private sector, you can look at the customer reviews and kind of generalize them and see whether they are saying that your product is good or not. Um, if you're more in my sphere in economics and in academic research, you can also look at stuff like, central bank communications to say whether like central bank has positive or negative attitudes towards inflation or stuff like that. In like court rulings, party manifestos, misinformation and propaganda, also find like what patterns there are there. And many people look at this text qualitatively, so they just, read this text and they kind of make patterns based on what they read, and this is very useful and informative, but often like there is such large amounts of text that you cannot possibly read all of it yourself. So in these situations, you may want to use quantitative tools to kind of automatically go through this text, and they will return to you in basically seconds, telling you which topics dominate, which sentiments are expressed, and many, many more other insights. So, as I mentioned previously, today we will to look at two general kind of methods on text analysis: traditional methods and LLM methods. Each of them has their kind of uh, strengths and weaknesses. So for traditional methods, obviously, uh, they are faster and cheaper because you do not have to pay actually for any LLMs, and they run faster. It's also easy to audit and understand why each particular decision was made. So, for example, you classify something as positive sentiment if it has word happy in it, and then you say like this text was classified positive because it has word happy in it, which is quite simple. Uh, but on the other hand, it struggles with things like sarcasm, negation, meaning like if you have the word not before the word, and context. In the context, LLMs are kind of more general purpose and they're more flexible. They, depending on which model you use, they understand context and nuance, but they can be more slow and more expensive. And obviously, they can hallucinate, so they can come up with wrong labels as well. I see there's something. Okay, it's just link. Thank you. Yeah. So uh, today we will try to kind of do both of them on the same data set and see whether the results are say similar or different and which kind of results hold better. So for if you want to, follow along, you can install these packages, but this is, not required for today's talk. So this is just if you want to run it later or today. And also, I will assume throughout the talk that you already have some, at least basic experience in R and in tidyverse, because we will use tidyverse as well. So first of all, let me introduce the data that I will use as an example. So this is kind of comes from Kaggle. So you can also download it kind of yourself. But initially it comes from this EU versus Disinfo project, which tracks pro-Russian misinformation in EU and Eastern Partnership countries. So basically, it's row-based data. So I mean, it has like one row, one claim, one false claim that they identify as false. And this is quite old data set. I've been using it as an example for quite a while. So it ends between 2015 and 2020. It's quite small relatively, so it's only 7,000 rows, but it also kind of makes it easier to process. So this data set, it has actual text, which we will show, and a lot of different sentiments. So you can like analyze that, and kind of you can analyze time dimension and different topics, which we will also use later. So I mean, the most obvious thing you can do is load the data set. I will not focus too much on it today because it's kind of the basic tidyverse. Again, if you know the tidyverse and used it previously. This data kind of comes from in CSV format. So here I just wanted to show you the columns that we will look at. So the columns that are interested in is this claim reviewed. So basically, which is what is the false claims that this project has identified. And here it cuts off a little bit, but it's kind of long, quite long text. So it can be a couple of sentences or a paragraph. And we also have a date when this claim was published. Um, so yeah, this is kind of the basic format we will work with. Uh, so first of all, let me introduce this tidytext pipeline. That is kind of the basic method or like the traditional method that was used often before LLMs. And to introduce this tidytext method, first of all, I wanted to introduce something that's called bag of words. So bag of words is the idea that like any text consists of words, and therefore, for this method, mainly what we will do is we will separate the text into each individual words and kind of analyze them separately. There are also extensions, so you can do use something that's called bigrams, where you analyze like a pair of words rather than each word individually. But the core of it is that you separate basically text into words, and then you um, like make a data frame with it with one word per row, and then you use your usual tidyverse functions to kind of let's say count the number of words and see what's the most popular word. You can plot it. You can group by, let's say, maybe part of words and so on. So here, as I said previously, token for the most part is a word, but it can also be bigram, which is two words, and gram, which is a number of words or like the full sentence. So how do we separate our full text into these tokens or words? This is very simple with this tidytext package. You use your usual pipe um, from dataset, and you use the command unnest tokens, and then you say basically at which level you want to unnest them. So here I separate each word into a single row, and then kind of you also convert all of the words to lowercase, because otherwise, if you have like a word at the beginning of sentence and the same word in the middle of sentence, it would be classified as two different words. And then basically, the size of the data set has increased a lot. So here we have 300,000 observations because, again, each row is the single word. And as you can see here, um, this worked. So we can see that like each row is one single word. Um, yeah. So again, if you have any question at any point, feel free to, write in the chat or unmute yourself. Um, but yeah, I assume that there are no questions if there's no messages. So another kind of concept to understand is stopwords. So if you deal with the data analysis quite often, you may see that pretty much in every text, there are a set of words that, are always the most popular because they are used the most often in English language, if we have English text. And so if you do not exclude them from analysis, your analysis will be quite uninformative because it will show basically the same words as most popular every single time. And luckily for us, there are actually lists of those most popular words that are not very meaningful, and they are available in the stopwords package. So there are several different sources in this package. So here I use Marimo package, and just to show you, which examples of these stopwords they have is kind of I, me, myself, and so on. So it's kind of very common words that are not really informative. So what we want to do is we want to remove these words from text before processing it further. So, I mean, yeah, as I said before, there are many different sources and many different languages in this package. So, choose whatever works best for your purposes. And how do we do it? So we remove this words with anti-join function, which also comes from the like standard tidyverse. So this is nothing new. It basically kind of compares the data frame stopwords and data frame articles unnested, and it removes from articles unnested all of the rows that are present in the stopwords data frame. And as you can see here, this by doing this, we have removed 133,000 rows, so it's even more than a third of the data, which is quite a lot. So it shows that like the stop words, they are very, very present in any data set. Yeah, so basically this is just says the same. You can also add your custom stop words. So for example, here, I decided to remove geographical names because they're also quite often mentioned in this text specifically. So you can just, make a vector of original stop words and like append to it any other words you want to remove, and then kind of do the same unjoin as anti-join that you did before. Okay, so I assume no questions on that. Again, I will maybe pause for a second if anyone has any questions. Okay, so then next, what we want to do, first thing, kind of the most basic thing we want to do is we want to uh, do some basic operation with this data frame that we created uh, after removing stop words, and this is just to calculate word frequency. So how many, what words are the most popular, the least popular, and so on. And to do so, as I said previously, you can just use the basic, tidyverse functions. So here I use count command, both on the data frame with countries names and without country names. And as you see here, uh, like if you do not exclude country names, basically 5 out of 6 um, top rows are country names, which makes sense because, this is mainly Russian disinformation in Europe. So, I mean, obviously, Russia will talk about themselves and also about Ukraine and US, which makes sense. But if you do remove it, you can see like other countries such as military, people, president, and so on. So again, that depends like which words you remove depends on what data you have and what's your purpose of analysis. So for example, if you analyze some economic texts, you may want to like remove like percentage word because often says like GDP rose by like 2.3%, so maybe percent would not be informative in that case. So again, it all depends which data set you want to analyze. What you can also do is you can do word cloud, and I will show you two different packages how to do it. So first package is word cloud, and for this you need kind of a vector of words, a vector of frequencies of words, and how many words you want to include. I mean, this is optional. You can kind of leave it by default. Then you can also specify colors because by default it's just all black, but you may want to like have kind of the most popular words in one color and the rest in different color. So here you can see this kind of word cloud. This shows the same basically as the as we saw in the top words, but kind of in a better format. This is the same, but without the country name. So I will not stop maybe too long on that. And then there is word cloud 2, but it doesn't show on Quartz unless you refresh the page for some reason. So let me do it. And yeah, word cloud 2, I think is kind of better package uh, from my personal preference again. Um, and I would say for several reasons. So first of all, it's interactive. So you can, for example, move your mouse to a specific word, and it will say how many observations it has. Secondly, again, personal preference, but I think it looks better than regular word cloud. Thirdly, you do not need to kind of summarize, group by, or count the number of words before processing it to word cloud too. You just take the data set on your own, and it will kind of figure out which column stands for, number of observations and which column stands for word. And yeah, you can also customize it. So for example, here I like only include words with more than 150 observations. And then you can also like change the shape of it, like not to be, a square, but for example, to be, I think you can do it in a shape of a letter even. So like can have like word cloud out of letters. You can customize colors and so on. So yeah, but this is personal preference, therefore I wanted to show you both. So another thing you can do and kind of uh, what I would say, okay, so there is question about GG Word Cloud. No, I actually haven't tried GG Word Cloud, but thank you for the suggestion. I will have a look at it. Um, So, I mean, another thing you can do is to kind of look at it as regular bar plot. And I think like the word clouds can be better if you want to put like a nice looking figure somewhere on your website or like in the media or in your paper. But for like this for yourself when you do exploratory data analysis, I think bar plots are kind of you know, more useful because here you can more easily see like the number of observations and so on. But again, this is like general standard ggplot, so I will not focus too much on that. But basically here my point is that, after you do this unnest token and do this back of word approach, you can basically do with this data set anything you would do with any other like normal data set with tidyverse, with ggplot, and so on. So another thing I wanted to talk about is sentiment analysis. So sentiment analysis, the one that I will talk about in this first part, uh, is dictionary-based sentiment analysis. So what it means is basically, so first of all, what is sentiment analysis? Sentiment analysis is kind of a type of analysis that allows you to see what types of emotions a certain text has or gives or explores. Um, and dictionary-based sentiment analysis means that you have a certain dictionary of words, and each word is associated with different emotion. So, for example, happy is positive emotion, sad is negative emotion, and so on. And then basically you connect this dictionary of emotions with your data set, and then you again do whatever you want with like basic tidyverse tools. You summarize, you plot the results, and so on. So there are several lexicons that or dictionaries that are directly kind of imported in R. And today I will show you AFINN, which is kind of integer, gives each word an integer score from -5 to +5, where -5 is most negative and +5 is the most positive. Bing Dictionary would just have binary measure positive or negative, and NRC Dictionary, which has 8 emotions, and also positive and negative. So first of all, we can join the dictionaries to our data set. Basically, again, this is very simple, very basic tidyverse thing. You just use left join function, and I get this dictionaries from get sentiments function. Um, and basically, I connect all of them on the level of word. And then I rename them so that basically each sentiment has kind of corresponding name to the dictionary it comes from, because by default they're just called sentiment. So after I do that, basically what I have is I have a data set where for each word, or at least which, you know, some words, which I will talk about later, I have a sentiment from NRC dictionary, from Bing, and from this AFINN dictionary. And what you can see here already kind of shows part of the problem with the dictionary-based method. First of all, here I filtered, uh, only those observations for which there is a score in this AFINN dictionary, and you see that a lot of words were dropped. Um, if you remember, like what was the previous like start of the uh, of this data set. And this is because these dictionaries that are not they are not infinite, right? So they have a limited number of observations. And as you can see here, basically sometimes they do not have any sentiment for a certain word. And for some words, like one dictionary has sentiment and another dictionary doesn't have sentiment. Uh, so also sometimes they can contradict like which sentiment it is, maybe not like one saying it's positive, one saying it's negative, but it could be like one saying it's positive, another saying it's you know another emotion that is positive but not strictly positive. So there is a lot of disagreements between dictionaries which can cause different results, um, which I will also show later. So first of all, let's look at this NRC dictionary. Excuse me. And NRC dictionary is the one, if you remember, that has like a lot of these different emotions. So here I just take, my data set. I only include the words that have sentiment from NRC dictionary associated with them, and then I plot basically which of the sentiment predominates in this data set. And you can see here, like positive emotions are on the first place, negative on the second place, and then fear, trust, anger, and so on. So this is kind of very quick, as you see, visualization, but it allows you to basically kind of, do this very basic plot and look what your data has. But what I wanted to show you also that kind of what I said before, that like different dictionaries on the same data show different story. So before we had positive and negative kind of emotions being almost the same, and positive a little bit higher than negative. But if you look at this kind of being sentiment data, you see that negative emotions dominate by much compared to positive. And this is kind of like another disclaimer, there could be different reasons for this. It could be because, Bing has maybe some more sentiments for the negative or measures for the negative words in our data set, and maybe NRC doesn't have kind of those words in the dictionary. But also the NRC has fear, anger, sadness, and so on. So like if you sum up this negative emotions, maybe it will also be much more than positive. But this is kind of just a disclaimer that, you shouldn't just do one plot and basically base your whole analysis on the one plot. Um, so another thing you can do is, this is kind of again just like some very basic ggplot. So uh, I just take this. So basically, after we connected the sentiments to the data set, everything else kind of so far has been just basic ggplot. But this could be like an inspiration for you if you want to, analyze your own data, text data, and see what's uh, what's interesting there. So what I do here is I look at which are the most common positive and negative words. So let me maybe uh, make it bigger. So this kind of shows you what partly drives it, and also kind of shows where some errors can come from. So as you can see here, so one of the most popular positive words is Trump. And like I would say that probably Trump most often refers not to like, good Trumps over evil or something like that, but to like, Donald Trump, who is president. And if he is associated with positive emotion is an open, let's say, question, but it's not in the meaning of that was meant in the dictionary when they wrote it, basically. So this is another kind of caution that some words have several meanings, and these dictionaries may only use basically one meaning of this word, and in your context it could be completely different meaning. So be careful with that and like look at which words are driving your results. Um, so another kind of yeah, let me look at the uh, okay, yeah. It's not a question. So let me look at another kind of inspiration of what you can do with the data. So if you remember, the one of the sentiment dictionaries I mentioned is AFINN, and this is a quantitative dictionary, so it goes from -5 to +5. So here you can kind of more easily, let's say, calculate the average sentiment and see how it evolved over time. So you can see like there was like a jump in this month to very negative, then there was a jump to like neutral, but overall it kind of stayed more or less negative all the time. But in your work you can examine if there are like certain positive or negative peaks in certain months and look at why those peaks exist there. So that's another kind of potentially interesting uh, uh, so yeah, see there is some questions. Is there some kind of standardization about the use of dictionary rather than another? How does apply when comparing different text? Um, so that's a good question. I don't know if there is, so it depends what you want from it, right? Because if you need like a wide range of emotion, uh, like this, let's say negative, just positive and negative wouldn't give you that. So you need that dictionary like NRC that gives you like all of this like joy and fear and so on. So I would say, yeah, it depends that, what you want to do, but also I would suggest maybe to do like several ones and see whether the results are consistent. Because yeah, otherwise, if they disagree, then look into um, mm, yeah, uh, before start analysis. Um, so another question: the sentiment dictionaries would be relative from one colleague to another. Would you recommend a consensus before start analyzing? Um, I don't fully understand what you mean. So you mean like agree with your colleagues if you're working on the same project? I would say yeah, because then yeah, so yeah, for sure. If you are working with your colleagues on the same project, for sure you should all like use the same one because otherwise you would have different results. Um, so for other languages, there's a question about other languages. It's a good question. So other languages do have their own dictionaries. Um, they are not always available in the R package as kind of pre-installed, so you may need to like search and find them in different sources depending on which language you use. So yeah, you would need different dictionaries. Um, and yeah, I mean, I think some of them are available in this get sentiments package. So let me uh, um, yeah, I mean, I think if you look at the like help file for the get sentiment package, you can look someone and uh yes, and otherwise, yeah, just depending on your language, just Google it. And yeah, the stopwords package, yeah, thank you for linking it. Okay, so let's go forward. So next kind of topic I will go very briefly through because it's a large topic and I won't be able to like discuss it in very much detail, but just to, I'll let you know that you can do it. It's called topic modeling. So topic modeling uh, basically allows you to separate your text into different topics, and then you can see like which words are associated more with kind of uh, each topic, uh, so that then you can analyze and like give labels to these topics. So this is kind of like a type of unsupervised machine learning. Specifically, we will use LDA or latent dirichlet allocation. And yeah, we'll talk about later how do we do it. But if again, since I will go quite quickly through it, if you're interested in more, you can check tidytext mining book, specifically chapter 6, I believe. Unless there is another edition now, and it's not no longer chapter 6, but yeah, in any case, it's publicly open textbook. I will also link it at the end, and I really recommend you this textbook if you're interested in this topic. Um, so for the uh, yeah, let me get back to the question after later because I will talk about that. So for the uh, topic modeling, first thing you need to do is to build something that's called document term matrix. So what it is, I mean, first of all, you again, as we did before, you like count the number of words, so like how many observations. Uh, yeah, thank you. Someone sent the topic modeling textbook. How many how many times each word is present in the text, and then you'll use this castdtm command, which basically creates a very, very large matrix where basically what you have is like you have words on the, let's say, x-axis, and you have um, number of document on y-axis. So let's say previously, before you separated like uh, the each article into individual words, you had like each article as a separate row, right? So what it does, it shows, let's say, article number one on x-axis and like each word on y-axis, and it basically says whether each this word is present in this article or not, and or and if it is present, how many times. And basically, this is quite a sparse matrix, what we call, because most words don't appear in most documents, but it kind of allows you to see which words cluster more often together. And this then kind of shows that if these words, appear together in this topic, then these two articles kind of belong to the same topic. So this is like very, high level explanation without like getting too much into math behind it, because this is very basic overview. um, and yeah, someone asked if we need to establish number of topics in advance. Yeah, you do need to do it, because otherwise, I mean, it's just the way it works. You kind of it will not know to how many topics divided. So here I use this LDA command, and important to set seed so that the results are the same every time. And basically what you get in the end is you get this LDA model, which I use tidy to kind of move it to like a tidy format. So what we have here is like all of the words, so this 0 and 0, these are all like words that at least once appeared in the text. Um, And here you have this beta column and topic column. So topic, since we specify two topics, uh, this topics one and two. And basically this beta column suggests what is the probability that this word appears given the topic. So in topic one, zero appears 0.0000111% of times. And this by itself is not very informative, right? But what you can do is you can plot, for example, kind of the words with the highest betas or probability of appearance for each of the topics. And this would allow you then to see basically which words are kind of more or less often appears in each topic. So here you see, you topic one and topic two. And there are several things. So first of all, you can just look at the words to kind of see which appears more or less in each one. But also here some words can intersect between topics, because sometimes some words like appear so often that they appear in both topics quite frequently. So we will deal with that later. I mean, for now you can see like that topic one, let's say, has Europe, let's say Western, so the words that are unique and not present in topic two. And the kind of a second topic has Ukraine, let's say NATO, and so on. So, I mean, this is more like about Western countries, and this is more about Ukraine, at least from this figure. But as I said, since some of the words show in both topics, what you also can do is to do something called log ratios, which basically measures how often this word appears in topic one versus topic two. So again, I will not focus on math here because we don't have time for this. But again, just to give you like illustration, when you do all of this, it gives you like the most popular, words for topic one that are really often present in topic one, but not topic two, and then the words that are really present in topic two, but not topic one. And this, for example, said that again, like topic one is like American and like Western. So this is really about like America and EU, so European states and so on. And this is about like Kiev, Crimea attack military. So this is about more war and like Ukraine and things like that. So this again another way of like dividing the topics, but then you can of course like need to do some more analysis and look at more words and so on to like actually determine what this articles are about and how you can phrase it. Okay, so very let me see the I mean, what is your process to determine the best value of k for given data set? So I wouldn't maybe spend too much time on that, but there are several methods. So like first of all, you can just like try different case, um, to and see what you get. Also, I mean, I recommend you reading this topic modeling book. They have kind of more math-based explanations. But yeah, I mean, there are like certain commands that measure like effectiveness and like the goodness of of a different case. Um, okay, so very quickly, let me also go through bigrams. So bigram is just a pair of words, and why you kind of you may want to use it is because sometimes combination of words give different meaning than just using single word. So the most common example of it is not. So not completely changes the meaning of word. If you have good, it's positive. If you have not good, it's negative. Also in economics, like from personal, uh, experience, I once analyzed data from IMF, I think, or text data, and it showed like a lot of sentiment of disgust. And I was wondering why it was the case. But the reason was that growth in itself means like bad, and gross domestic product is just like very common economic term. So it kind of deducted it as, as negative. So that's why you may want to look at like pair of words rather than single words. How you separate articles into these bigrams, very simple, like exactly the same way as before, but in the unNest tokens command, you put bigram instead of word, and then you basically specify that tokens is n-grams and n in the n-grams, so how many words is equal to 2. So what this does, it basically, creates each row with um, two words that are next to each other. And, important to notice is that like the last word in the first bigram is also the first word in the second bigram. So they kind of, not to take two words and the next two words and the next two words, but like first, second, then second, third, and so on. And what you can actually do with this kind of words, first of all, you may want to filter stop words. Um, and at least the way I do it is I separate them into two different columns, word one and word two. Basically, you can separate them like whenever there is a space, you separate it into two different columns. And then basically you filter um, out observations where uh, either both of the words are in stop words or at least one of the words are in stop words. This depends on like what you prefer. Do you prefer to be more kind of, strict with it or not? Uh, but yeah, I mean, and then you can, when you separate this bigram into two columns, you can also do things like count and see what are the most popular combination of words that are most often used together. So for example, here, like it's United States, which makes sense. It like have United and then followed by states. But often it can be quite informative. What you can also do with the bigrams is that you can catch where sentiment mistakes were made. You cannot really catch like all of the mistakes, obviously, because of the other issues we discussed before, like words having different meanings and like not the dictionary not having all of the words, but at least you can catch part of them. And what I do here, as just an example, is I look specifically in for the bigrams where the first word is not. So the logic here is that if the first word is not, then the second word would like reverse its meaning. So if we classified it as positive, we actually should have classified it as negative. And what I do here is I join this AFINN sentiment that is quantitative, so we can actually, look at the number of by how much we overestimated or underestimated positive sentiment of the second word. And basically, I calculate, the number of times this word was present multiplied by kind of the negative or positive score from this AFINN dictionary. And then I can also plot like what are the most popular or like most sentiment words that contributed most like positive and negative score. And you can see that like not want was like one of the most popular, and then like not interested and so on. And then you can also like calculate the net bias, basically, which is the sum of this contribution that I calculated earlier. And basically, if it's positive, it means that positive number that we overestimated how positive this text is. So actually, it's more negative than we, calculated according to this score. So this is another, reason why you shouldn't blindly rely on the dictionary-based sentiment analysis and why you kind of should do more work than that. And finally, with like the dictionary analysis, what I wanted also to show is kind of how else you can plot like bigrams and combinations of plots. You can plot it like a network if you're familiar with the network analysis with this package gggraph. Basically, what this does, it shows kind of which two words are connected to each other. And you can also see like sometimes it's kind of like full combination of words. So you can see here uh, like European Union, then followed by Parliament, but also so European is often followed by Parliament, but also followed by Union, but also followed by country. So you can see like some combination of words. And like for example, some words are quite isolated. So like air is only followed by force. Sometimes you have like a three words that are often repeated but from each other, like last week's trend, and so on. So again, depending on your topic, this can be quite useful to see what patterns you have in your data set. Um, Yeah, so someone messaged about networks, uh, package networks to build network of words that uses gggraph. Yeah, thank you so much, Alison. I will check it out as well later. Okay, so if you don't, let me make a pause for a second and see if anyone has any questions on this. But basically, what we did is we kind of followed mostly tidyverse package, tidyverse syntax, and kind of after basically using this unnest token and kind of merging the sentiment analysis, sentiment scores by dictionary, everything else was pretty much like just like ggplot and kind of tidyverse functions. Okay. So I don't see any other questions. So let's move to the part two, which is LLMs for text analysis. So I assume that you are familiar with, large language models. They're everywhere. There are a lot of them right now, and kind of every basically week there are like something new happening with them. But basically, what these large language models are, they are kind of trained on a very, very large data sets to predict what is the next token on the text. And because they're trained on such a large data set, they have seen like a lot of examples of like words being together in a sentence rather than just on individual words. So they may kind of identify not just whether these words are positive or negative, but they can identify things like, sarcasm, and they can answer your questions basically about text, not just like say whether it's positive or negative. So they're much, much more flexible. But at the same time, you should be careful with them because they, depending on the model and depending on how you prompt it, they can hallucinate, and make things up and like not tell you the real result. And I mean, there are very many providers these days. So what I will show you, you can basically do with any provider as long as you have like the API code and like tokens. So some of them are paid, the local modules are free, but again, it's up to you which one you prefer. So today I will show you mainly how to work with these local models with Ollama. And again, this is just because it's free and it's easier to like demonstrate so that everyone can follow. But if you want to do, real work and real like kind of analysis for some serious purposes, it may be better to pay for like some more powerful model. Although for more powerful model, you have keep in mind that data can go on their servers, and if it's like a confidential data, then you probably shouldn't do that. Um, but even these local models, they are getting much better these days. So for some tasks, they are kind of good enough to perform analysis. Um, okay, so first of all, what you need to do is you need to download this Ollama. So this is kind of an app, and it also installs all of this like uh, free local language models. And there is a like dedicated package in R that pulls these models into R. And just a warning, first of all, you need to open it once after you download, because otherwise there could be problems with R identifying it. So like if you just downloaded it and never opened. And secondly, it's quite large. Even if we call it like small and like local, it's still in the name that it's large language model. So it's quite large in terms of memory size. So, be prepared that it can take a while, and it can, if you don't have a lot of memory in the computer, it may be problematic. But basically, you can, with this pull command from a Llama package, you can basically pull any or like make sure that it will be used any of the models that is installed through the Ollama, and kind of use it to classify text in R. So this is just a basic overview of what we will do. We will kind of use this function from the small package. Uh, and they're quite flexible. So there are some standard things like sentiment, which gives you the sentiment of each row or of your data. And here you do not actually need to divide them into words beforehand because like LLM can, read the whole sentence and tell you which sentiment it is. So think of it as like you copy paste in a sentence into ChatGPT and asking like what sentiment is the sentence. It can just like tell it about this whole sentence rather than like word by word. And therefore it avoids this problem of like negation and so on. You can also use LLM classify, which assigns basically any custom label you want, and we will look into it later. You can extract certain info, tell it to extract like if this like text mentions a name, what's the name that it mentions. You can make it summarize the text, answer yes or no question, translate the text, or like basically, input any prompt. So for the like most of it, we will use just like pre-installed data. We will get back to the uh, data we used before at the end, but this is easier because it's like much smaller. So this is just like some fake reviews for fake products. This comes with a mall package. Let me see. Uh, does Ollama mall work on web pages? Um, I'm not sure what like it has to be installed on your computer to run. So I guess it depends whether it's installed where the web page is hosted. Um, yeah, I haven't used it in that scenario, so I'm not 100% sure. Um, but anyway, so here you see like kind of positive review and negative review and kind of not clear review. So this is interesting because it's not clear a priori how it would classify it. So if you just do like LLM sentiment, it will just give you positive or negative, which kind of, you know, matches quite well, I would say. Like the last one, it identified as negative, because it has to give you like a binary option, and like it reads maybe more negative than positive. So it's kind of subjective. So, be prepared that it makes it this subjective decisions. But other than that, at least for the positive and clearly negative, it's kind of clear. Um, Another thing that you can do is you can like custom label, uh, put custom labels. So here you use LLM classify rather than LLM sentiment, and you say that like classify into these categories, and you give it categories beforehand. So here you can give like neutral category, and because this is no longer binary, so it classifies this, last review as neutral. So this kind of makes more sense than a previous classification. You can also basically put any label you want to. For example, like product complaint, shipment complaint, praise or question. Uh, and like here, I would say it doesn't do as well of a job because it says that the third one is a question, but this is like they're not actually asking questions. So they say not sure how to fill. They're kind of just, wondering how to feel. But again, maybe then it's more accurate to call it question than complaint because it has like part of praise, part of complaint. And since like it can allocate only one label per each category, again, maybe question is more accurate. So this is very subjective, as you can see. So what you can also do is you can extract structured fields. So you give it the review, data set and tell extract product. So basically it knows that from each review it has to extract which product this review is about. And here I would say it does pretty good job. So here would like if you did it in traditional way, you would need to have like a dictionary uh, of all of the possible products that can exist and say like extract one of this, or you would need to know where in the sentence the product is and write some complex regular expression to extract it. which kind of can be complicated if it's not always in the same place. But here it does pretty good job, with just this very simple command. Um, yeah, and also you can ask several things at once, so you can like extract product, brand, and feature, for example, or whatever you want. Uh, so is it possible to give examples to the LLMs or definitions of the element to extract? Yeah, so there is like LLM custom command, which we'll go to later, that gives you much more freedom to give any prompt that you want basically to it. Can this local LLM model perform well in languages other than English? So it depends which languages, I would say, because I think like the less spoken the language is, the less kind of examples in its training data set. Yeah, Spanish, I would say probably. I haven't tried it, but I would say Spanish probably is kind of very, popular and widely spoken. So I would say it probably has enough examples online to train on it. But I will show you later, like the LLM translate function. So another thing is to summarize, which I mentioned. It basically summarizes the review into like how many words you say. And here, like, sometimes it's not completely accurate. So for the first one, it says I completely agree with you, even though it's just like about the TV. So I don't know uh, if it's accurate. So the another question is, can LLM sentiment give a numeric output, like -5 to +5? I would say, maybe better to do it with like LLM custom prompt or LLM classify. Yeah, to if you want like very specific kind of numeric variables. Okay, so another thing you can do is answer a yes or no question, and this gives you a binary result. So here you just write the question. So here, for example, I write, is the customer happy with the purchase? And then for the first one, it gives 1. For the second and third, it gives 0. So which kind of also makes sense. And this already is using numeric, so it's kind of, you can put it into regression. You can do whatever you want with it because it's quite simple to use like the binary numbers. So then you can use LLM translate. So here, since it's our lady's Rome, I translated it into Italian. So I'm not maybe the best judge of Italian. Maybe Federica can say if it's accurate. Uh, I I would say for my class which was like half a year ago, and it was completely different local models then, and I translated it into Ukrainian. It was horrible. So I don't know. Now I think it's improved quite a lot. Uh, but yeah.
Yeah, I can say that the third one, for example, non sono sicuro di come sentirsi per la mia nuova lavatrice. That is not actually correct, but
Okay.
it makes sense. So, as an Italian, I can understand the meaning, and so um, obviously, I guess it can be improved.
Okay. So it's not perfect, but it's understandable. Uh, and that then there is uh, yeah, then there is like LLM custom basically commands that where you can like give any prompt, and someone previously asked, if you can do from -5 to 5. Here I think it's the easiest kind of way to do it. So here, for example, the prompt is answer a question, return only answer, and acceptable answers are yes or no. And here you see that it didn't actually answer it correctly, but it only returned yes or no. So how good it is, you can judge. But again, this is like local LLMs with like with if you collect like Claude, Opus, or something like that, or GPT 5.5, it will be much better. Um, so this is again another thing that is important, that for if you do this custom prompt, it's very important to like specify what format of output you want it to return. Otherwise, it will be like, it will like return very long text for each answer. Okay, so I promise you to return back to this information data that we worked with, and here just to compare this to like our dictionary-based analysis. I use LLM sentiment, where it just classifies each sentence into positive or negative, and also LLM classify, where like I try for it to come up with topics for each out of these categories. And here, as you can see, it's on the level of sentence rather than on the level of like individual words. So it's kind of hopefully wouldn't make mistakes like we had before with like not and then word followed after it. Uh, so as you can see also, this is quite short code to do both like sentiment analysis and topic modeling basically at the same time. But on the flip side, you need either like LLM installed, or you need API tokens from one of the providers that you prefer. Um, so let's result depends on the version. Yeah, for sure. Version. So Ollama is actually uh, not. I mean, if you, Ollama is our package, but like Ollama, the app, it has like different local models in it. So I mean, when you update it, it like installs more up-to-date models, and obviously these local models they update all the time, and like the newer ones are usually better. So yeah, I mean it improves all the time basically. Um, so yeah, I mean also obviously it can be not accurate. So if you like do it depending on kind of compared to human labels, it it can like the accuracy depends really much depending on like which text it is, which model you use, and so on. Sometimes it also, even if you tell it to like only use these labels, it can come up with like new labels by itself, so it's not always follows your instructions. So my kind of advice is to like, let's say, run this, and then let's say take 10% of your data, or like 1% depending on how many observations you have, and kind of check manually the accuracy of this 1% of the data, or 10%. And if it's like, if it's 90% accurate, or like 99% accurate, it's good. If it's like 30% accurate, then probably you shouldn't be using, the this LLM for this text. Um, so yeah, but also the question often is not whether it's better than human, because if you have like a billion of different texts, you cannot physically read them all, but whether it's better than dictionary. And in this case, it often is. So I would say, yeah, but kind of this depends on what exactly you want to have. So I would say that LLMs and dictionary, they all have their strengths. So for LLMs, as I said previously, they kind of can analyze the sentences all together, and they can detect like context, sarcasm, and so on. You can also, use them for open-ended questions. So here, previously in the dictionary-based models, we just looked at kind of sentiment analysis, where for LLMs, you can ask them any question, like what product it talks about, and so on. Um, and then dictionaries also do not have kind of the all of the words. So, if you have very specialized text, or if you have language in which the dictionary doesn't exist, then like LLM can be your only choice. On the other hand, LLMs, they are kind of a black box. So, you see their output, but you don't know why they gave you this output. Whereas with dictionaries, you can say, okay, it detected this word and this word and this word, and therefore it classified as kind of as a positive sentiment. Um, Also, dictionary-based analysis is more reproducible because obviously when you run LLM, every time you can get a different result. Um, and also, you may not have budget to like pay for a good, let's say, LLM like Claude or ChatGPT. So in that case, you may need to like run it on just dictionary. So I would say which one to use depends on the situation, but as LLMs develop, they are getting better and better. So I would say kind of with time, this answer would more lean into the side of LLMs. Um, so, but also, you can o often do both. So just running like a sentiment in addition to LLMs, just running like sentiment analysis kind of takes, 5 seconds, and this allows you to compare and validate whether like what's the match between them. And if there is a good match, then you can say that like the results are consistent and it's all good. So I would say often, if you can do both, it's useful to compare them and see what are the problems and what are the mistakes in both. So yeah, I would say there are like complements, not substitutes. So before, maybe before questions, let me just wrap up. First of all, I've linked some resources here. So first of all, this is tidytext mining book that I, mentioned. Also the tidytext mol package that are kind of the most often used. But also, you can see the full list of packages at the start. Also, there is Elmer package, which I didn't have chance to mention today, but is also very, very good. This kind of gives you more flexibility to use LLMs in R. There is also Ollama link where you can install it. And finally, there's a good repository of like data sets or for text mining if you want to practice on kind of real data set on whatever topic you're interested on. So another thing, first of all, this is my email. If you have any questions, you can say here. Also, as I said, as Federica said, I run these workshops for Ukraine series, which is also on R, Python, and so on, and you can find them here. You can find, my slides on the GitHub. And that's it. Thank you so much for your attention. And yeah, if you have any question, uh, I will be happy to answer. So yeah, I see there are also already questions. So the PowerPoint shared, so it's not actually PowerPoint, it's a Quarto presentation. And you see the link here, at the top. You can go to it. It's available publicly, but also it's on my GitHub. Uh, if you click here, view the slides, it will be accessible. I believe Federica sent the GitHub link in the chat, but I can send it again. Let me do it. Okay, so then another. Okay, yeah, someone else sent it as well. Uh, yeah, can our developers keep us up in Python packages? I mean, I'm not our developer, and I'm not using Python that much, so I don't think it's a question to me. Um, yeah, thank you for everyone who attended. Yeah, uh, yeah, the question about so I'm not really actually doing a project on this information. I'm just using this as a test data set. So this is kind of just, for illustration purposes. I'm not using it in any research. Um, yeah, but in any case, so I think if there are no other questions, I can stop sharing. Thank you so much again for attending and for having me.
Thank you very much. Thank you for joining us and accepting to speak for us. So that was great, very informative, great insights. So I really appreciate it. And so I look forward to maybe hosting you again in the future.
Yeah, I will also be at Use R conference in Warsaw. So if anyone is attending, maybe see you there in July.
Yeah, that would be great.
Okay.
Thanks very much.
Thank you. Bye.
Okay, so we will post the recording. We'll send an email with a little summary, all the resources and the recording. So stay tuned, and we will be happy to have you again for our next event on the end of June. Thanks very much for joining
Thank
us.
you.
Thanks.
Bye.
Bye bye. Bye everyone.